Find the derivative of y equals 2x plus 1 over x squared times x minus 2 over x. Then evaluate y prime of negative 1. So y is made up of the product of two functions, 2x plus 1 over x squared, and then times x minus 2 over x. So one option is the product rule, but that can overcomplicate it if we can physically take the product, and we are going to be able to physically take the product by multiplying the numerators and the denominators to get it to a single fraction. The numerators, to multiply them, it will be a FOIL of 2x plus 1 times x minus 2. The denominators, to multiply them, x squared times x, you just add the exponents, x to the 2, x to the 1, 2 plus 1 is 3, so that'll be x cubed. We will now FOIL out that numerator. So first, 2x times x, 2x squared. Outside, 2x times a negative 2 is a negative 4x. Inside, plus 1 times x is plus 1x, or just plus x. And then last, positive 1 times negative 2 is negative 2. All this is over x cubed. Now the outside and inside terms are the same and can combine. So we will have 2x squared minus 4x plus 1x, which is minus 3x, minus 2. And then all of this is over x cubed. Now right now we have a quotient, and one option is the quotient rule, but if you can physically take the quotient, it's often easier that way. And that's possible when your denominator is a single term, because each of the terms in the numerator can be written over that denominator term, and we will now do that. So y is going to equal 2x squared over x cubed minus 3x over x cubed, and then minus 2 over x cubed. Each of them go over that common denominator of x cubed. Now in the first term, 2 of the x's can cancel out. We have x squared and x cubed, and we can cancel 2 of them. With 2 of them from the denominator, that'll leave 1 left over in the denominator. So that'll become a 2 over x. In the second term, we can cancel one of the x's from the numerator and one of the x's in the denominator. Cancel this out with just one of them. That'll leave 2 of them in the denominator. So that'll become negative 3 over x squared. And nothing to cancel for the third term, so we'll just leave it the way it is. Now each of these terms are now added or subtracted together, and so each one can have its derivative taken individually. Since we have a number over x, we can rewrite each of these by using a negative exponent. So we can now write this as 2x to the negative 1 power, bring it to the numerator and call it a negative exponent, minus 3x to the negative 2 power, and then minus 2x to the negative 3 power. At this point, each of these are now a power rule, and we can find the derivative y prime, which can also be written as dy dx, and it will be, for the first term, a power rule, bring down the negative 1 multiplied times the 2, negative 2. X to the subtract 1 from the power, negative 1 minus 1 more will be negative 2. The second term, bring down the negative 2, multiply with the negative 3, that's a positive 6. Subtract 1, negative 2 minus 1 more is negative 3. And then the third term, bring down the negative 3 times the negative 2, that's again a positive 6. And subtract 1 from the exponent, minus 3 minus 1 more will be a negative 4. There's our derivative. We can write one more step where we take the negative exponents and move it to the other position, which will be the denominator, and call it a positive exponent. Negative 2 over x squared plus 6 over x cubed plus 6 over x to the fourth. And there's our derivative. The other thing to do is to evaluate y prime of negative 1. That means to plug a negative 1 in for each of the x's. Negative 2 over negative 1 squared, plus 6 over negative 1 cubed, plus 6 over negative 1 to the fourth. The first term, negative 2 over negative 1 squared, is a positive 1. Negative 1 to any even power will actually be a positive. Negative 1 to any odd power will be a negative 1. So this next term, we're going to have a 6 over a negative 1 cubed, which is going to be a negative 1, because there's 3 of them. Every pair becomes a positive 1, but an odd number will give you a negative 1 left over. And then the last one will be a positive 6 over negative 1 to an even power, which will become positive 1. The first term, negative 2 over 1, divided by 1 keeps itself. The second term, 6 over a negative 1, will be a negative 6. And the third term, 6 over a positive 1, will stay a positive 6. Negative 6 and positive 6 can cancel each other out, and it looks like our result is going to be negative 2.